We are finishing chapter 9 and we're doing two dependent samples, matched pairs. So the key concept here is we're going to be testing using hypothesis testing and constructing confidence intervals. And just recall that a matched pair has some sort of relationship, like a before and after measurement from maybe the same subjects, or IQ scores of husbands and wives, or we're looking at males and females in different kinds of matched situations. So just a reminder, this comes back from chapter 1, but matched pair designs compare two treatment groups, before and after, or it could have to do with twins. A test of Crest toothpaste used matched pairs with twins where one twin used Crest and the other used another. You could have like a placebo and treatment. So there's lots of different ways, but these are those kinds of situations. In general, good experimental design is just dependent samples rather than two independent samples. And this section is going to be pretty similar to 8.3. So let's talk about inferences about differences from matched pairs. So we can do hypothesis testing or confidence intervals. Here, this is the notation. Mu sub d is our mean value of the differences d for the population. So we'll be using that. And we're talking about the differences. There's going to be a lot of data entering in these problems, so just get ready for that. So the requirements are that the sample data is a matched pair or dependent. They are simple random, and they're either significantly large over that n over 30, or they're normal. So what we'll be doing is the null hypothesis is going to have the mu d, or difference mean, is 0. And this is really important. Right here, we're going to be doing this first. Let me turn on this. So we'll enter the data into L1 and the data into L2, and then we'll type in to store the differences into L3. So before we get started, you may have your L1 and L2s missing, and you may end up wanting to store your data in different lists so you don't have to keep typing it in, and that's totally fine too. But if you end up that you can't find your L1 or L2, or you accidentally deleted it, if you go to stat and then type setup, go to number 5, setup editor, and hit enter and run that, you'll get all your L1s, L2s, L3s. You'll get it all back. Then we'll be using for hypothesis testing, we'll be doing t-test and go from there. So in this section, we're going to see that everything is equivalent. Hypothesis testing and confidence intervals, they're all going to give us the equivalent sense that, and so we want to make sure the null hypothesis is that the mean difference equals 0. Okay, and so that way we can determine whether the confidence interval includes 0. We're still wording our final conclusions the same way. Now in this example, I do give the differences just so you can see them, but we'll assume that we actually don't have those values. So the data here lists the ages of actresses when they won Oscars in the category of Best Actress, along with the ages of the actors who won the Oscars in the category of Best Actors. The ages are matched according to the year that they were presented. This is a small random selection of the available data so that we can better illustrate the procedures of this section. So we're going to use the sample data with a 0.05 significance level to test the claim that the population of ages of best actresses and best actors, the differences have a mean less than 0. Okay, what the heck does that mean? A mean less than 0. The differences have a mean less than 0. Well, I'm looking at the differences and they're all negative, except for that one. So what does it mean when the differences are less than 0? It means that in this case, if this is our group 1 and group 2, that the actresses were actually younger than this. So when we're asking about the mean less than 0, we're saying, are the actresses younger than the actors? That would mean that the differences, right, are going to be less than 0. So that's the claim, that the actresses are younger, or that the mu sub d is less than 0. So our null hypothesis is always equal to 0. And so that means our claim becomes our alternative. This is our claim. Right. And so what we're going to do is we're going to actually enter this data into the calculator. We're going to go into stat. And again, if you lost your list, go into stat, click setup editor, and then enter. And now you're going to get all your data back. And we're going to hit enter for here. Now, if you want to clear your data, hover over it, hit clear. It looks like it's not gone, but when you go down, it is. I do suggest storing your data in here. Oops. into different L's so that you can not have to keep typing it in. I'm going to keep typing it in so that we have consistency. Whoops. But okay, so I'm going to type in the actresses for L1 and the actors for L2. Now, I suggest you pause the video and enter it in yourself so you can do these with me. I'm going to assume I don't know the differences because we never usually get the differences, and just double check over that the numbers match up and that I typed them in correctly. And then I'm going to go over here, a second mode, to quit. And I'm going to say, okay, I want L1, so second one, minus L2. I want the differences to store in L3. And I'm going to hit enter. And then I'm going to go back into my list just to make sure, boom, there they are. L3 is my differences. Now, I'm going to go into stat. I'm going to go into tests, and I'm going to go to t-test. And my data. So I'm talking about we want the mean to be 0. Now, the list is actually in L3. I'm looking at the differences is what I'm really interested in. My frequency is 1. And I am going to, my alternative hypothesis is less than. So I'm going to hit less than and calculate. And then I end up getting a test statistic of negative 1.557, but a p-value of 0.097. So p 0.097. And I'm going to use the p-value here. And is this less than or equal to my significance level? It is not. So I'm going to fail to reject the null hypothesis, which basically means that I am accepting, essentially, the null hypothesis, which means that the difference is 0. So what that means in this case is that there's not sufficient evidence to support the claim. And I can take it one further to support the claim. So that means that the differences are, there's not significant differences. The differences are pretty close. The actresses are not always younger than the actors. So there's the interpretation. So let's do example 2. So for example 2 here, we are given new data. And this one has the number of words spoken in a day by each member of 6 different couples. And it wants to know the claim, test the claim that among couples, males speak fewer words than females. If males speak fewer words than females, then that means if I was to take the male amount of words, and if they were smaller than females, then the difference between the two of these, what kind of numbers would I get? If the males were smaller numbers, that's what we're assuming. These are larger. If you do a smaller minus a larger, you're going to get negative. So what this really is saying is that the difference is going to be negative, that the difference is going to be less than 0. That's the claim. So our alternative hypothesis is not equal to, the difference of these two would be less than 0. And then here we're saying that the difference would be the same, 0. So let's go ahead and type these in. Now I do encourage you, we're going to come back to some of these later, but so you're welcome to change your L's and do something a little differently, but I am going to just do everything the same. So I'm going to clear out my L1, clear out my L2, L3, and type in all this data. I encourage you to pause this and enter the data on your own. Let me see if I can move this guy so you can see. Pause and enter the data and press play when you've got it in. So check that your numbers are the same, that they're matched up, and then we will quit and we'll do L1 minus L2. We want to store that into L3. So it's there. We'll go into stats, test, t-test, and our data is already in L3, and this time it's still less than. So we're going to hit calculate, and we get a p-value of 0.3256. 0.3256. 0.3256. So our significance level is 0.05. So can we reject is it less than? No. So we will fail to reject the null hypothesis here, which essentially means that we're accepting it, which is not our claim, right? This was our claim. So basically we're saying there's not sufficient evidence to support the claim. that males speak fewer words than females. Because if the difference is equal to 0, then that means there really isn't much of a difference between the two. So go ahead and give this one a try. Press play when you're ready to see the solution. And there you go. We'll stop there in part 1. In part 2, we'll do the critical value method and hopefully the confidence intervals. Otherwise, we'll have 3 parts for this one. Stay tuned.